In this video, we're going to be taking a look at how to do a pragmatic migration of servers from on-prem to Azure Infrastructure as a Service. We've recently finished our 50th Azure migration project. That seemed like a good opportunity for us to sit back and have a review of what we've done over these projects. We've gained a good reputation with customers and with Microsoft for being able to very pragmatically do Azure migrations. That's paid dividends for our customers because we've been able to move them quite rapidly with minimal risk and minimal disruption. So what we're doing in this video is going through some areas to share some of the things we've learned about migrations. So these are the areas we're going to cover off in the next sections of this video. I'm a huge fan of Stephen Covey and the 7 Habits of Highly Successful People. The one habit that has always struck out to me as being most powerful is beginning with the end in mind. What does beginning with the end in mind mean for an Azure migration? Well, essentially, I think you need to have a plan for these things. Now, as we go through our approach in the next slides, we're going to take a look at how we cover off each of these considerations and making sure that we've got the right design and the right implementation in place. Azure is a complex beast. There are a lot of things that are done for us by default with Microsoft, but there's a lot of things we need to do for ourselves, both in terms of migrating and actually operating our workloads. So, as we've done the last 50 Azure projects, these are the things that we've learned need to take into account. These are the things we need to have a plan in place for our implementation. Having a phased approach for your migration to Azure is pretty powerful. What it means is you can focus at a particular time all your efforts on getting a particular part of the project done. Also with Azure, there's this big question of, is it the right platform to run? Is it going to be cost effective? You don't want to have to wait till you've done the entire project to find out that it's going to be too expensive to run your workloads in Azure. The phased approach we take is basically structured down into the following phases. Discovery and assessment, where we take a look at the as-is environment and find out what needs to change or be remediated to run in Azure. Design, which is all about making sure that what we build in Azure, what we migrate into Azure, and what we configure in Azure is fit for purpose. Now, most organizations aren't really aware of the full kind of capabilities that Azure offers for operating. For some companies, having a service with a service level agreement of 99.9% for most applications may have previously been unobtainable, whereas now it's quite almost low-hanging fruit with Azure. Then during the remediation phase, what we'll do is take care of making sure that servers and workloads and applications are configured correctly so that they'll run in Azure. Azure offers us some really good advantages, one of them being Azure Site Recovery Manager, which we use as our main migration tool. It gives us the ability to do non-disruptive testing. That means we can scoop up your as-is servers, move them into Azure, put them in an isolated network, and do some fairly intense testing on them without impacting on production servers. End users are never going to know about this stuff happening and nothing's going to be damaged as a result. That means when we come along to execute the actual migration, we've already had a chance to go through these machines, through these migrations, and make sure that everything's fit for a purpose. The great thing about the Azure migration tool set that we use is the actual migration will probably only result in no more than an hour's worth of service outage. Once we've got machines into Azure, we then need to onboard them onto management. That means making sure that management agents are deployed, that machines come across have got the right monitoring and management rules in place for them, that the right disaster recovery orchestration is created for them. On an ongoing basis, once you've got workloads in Azure, they are going to need to be managed, and you're probably going to want to optimize these workloads as well, even if that just means as little as making sure you're paying the right price for your virtual machines or the lowest possible price to run these workloads. What we've learned is that you don't have to move all of your servers to Azure. In fact, there's probably going to be some servers that need to stay put. Take, for example, domain controllers, and specifically your DHCP service. You may need to leave that on-prem. You may need to have applications that need to stay on premises because of data governance rules, but not necessarily all of it. You don't have to move all your servers in one go. We found it really powerful with larger numbers of VMs to break down the migration into phases. And we execute migration sprints. We'll typically move about 25 servers in one go. That's helpful to the business because it reduces the amount of risk we're undertaking in one particular migration. And it also means that we can apply like a roadmap of migration as well. So if there's a lot of remediation work to do, we can do it in a phased approach. With Azure, you don't have to manage everything yourself. Microsoft are going to take care of a big chunk of looking after this platform for you, but there are definitely some bits of management that you need to take care of for yourself. And quite often that's things like configuring resources and configuring and operating management tools. Not everybody knows the management responsibilities that need to be undertaken. One of the lessons we've learned is that it's very unlikely that the Azure environment you deploy day one is going to stay the same. Your resources are not going to be static. Because why? Well, you'll want to try and keep the cost as reasonable as possible. Your business requirements are going to change, and the cloud is going to give you easier ways to do things over time as people like Microsoft and Amazon continue to innovate. The management tools, automation and security capabilities that you start off with in Azure are not going to be the ones you need 2, 3, or 5 years from now, because new versions of these tools are going to kind of come out that are more powerful. And you're going to want to make sure that your management approach and your management processes are continually enhanced to meet that. It's also, sadly, very unlikely that the people and processes inside your organization are going to be able to change the way they deliver services and manage technology overnight. Human nature just tells us that change can be difficult. So this is why we take a phased approach. A big part of this approach is not just to move the workloads across, but also as well as to help people and processes prepare for that migration so that they're able to hit the ground running in Azure. Let's take a look at the discovery phase of an Azure migration. The goals of discovery are to find out about the servers that we currently have. We need to gather inventory, configuration information, capacity information. We also need to map out the as-is software stack. So what operating systems are running, what runtime environments are running, what database platforms are there. It's also important for us to identify the as-is hardware and any private cloud stack. So any VMware, Hyper-V, or third-party hosting facilities that are used today on-prem. Fortunately for us, Microsoft has provided some tools to help automate this, and this can really shortcut quite a long and painful experience of having to refer to a configuration management database, having to have engineers do manual discovery. Now, there are some circumstances where it might be necessary to do that kind of manual discovery, but more often than not, the Microsoft Planning and Assessment Toolkit and the Azure Migrate Toolkit will help us with this. MAP's quite a powerful and well-established tool. It will basically discover computers from Active Directory or from a list of servers that you can give it. It'll then query those machines, and it'll ask it the questions we need to get answers for. Azure Migrate currently, at the time of recording, is optimized for migrations from VMware to Azure. The idea being that those VMware migrations are going to be a little bit more complicated because there's a change in the virtualization platform that just isn't an issue with Hyper-V migrations. The way this works is that a systems administrator downloads and configures a virtual appliance. That's just a virtual machine that'll be installed on the VMware farm. That virtual appliance is going to work with your vCenter server to identify all the configuration and capacity information about your ESX and vCenter environment. It's going to get some raw metadata from that, bring that back to an appliance called the collective virtual machine, which is going to pass the information back to a cloud service called Azure Migrate. All that information is going to be assessed using some artificial intelligence rules run by Microsoft and presented in the Azure Migration Portal as an assessment report. That's going to give us a huge amount of information that we can use to actually plan the migration when we move into the next phase. The assessment phase is really important. It's during this phase of the project that we're going to figure out what it's going to cost to run some of these servers in Azure. It's also where we're going to find out if there's any remediation work that needs to be done. So there are some remediation aspects like deploying some additional software updates, which is quite easy, or changing the configuration of a virtual machine, which is quite easy and can be readily automated. But there are also some readiness checks that need to be undertaken that can require some fairly heavy lifting. That's usually things like upgrading the operating system that a server runs, or upgrading the SQL Server database that's running on a server. Fortunately, there's a bunch of tools that Microsoft make available to help with this. So when we get into this phase for our customers, we'll leverage the Microsoft Assessment and Planning Toolkit, the Azure Migrate tool, Azure Site Recovery Manager and its planning tool. Also, the Operations Management Suite, which is Azure's management platform, provides a number of solutions packs that are going to help us with this. Service Pack, which we'll talk about in the next section, help us discover dependencies. Windows Update gives us an ability to plan and orchestrate deploying software updates to help remediate machines. Also, the Windows Upgrade Solution Pack is going to help us identify and plan upgrades for operating systems to get the Windows machines running the latest version if that's necessary. The Azure Pricing Calculator is going to give us the ability to have a pretty accurate feel for how much these virtual machines are going to cost us to run them in Azure. Then we'll also leverage Cloud9, which is now called Azure Cost Analytics, to help us say, okay, how are we going to optimize these workloads to try and bring down the running costs as much as possible. When we're doing a phased migration, it's not always necessary to move all of our servers together in one migration. There are also some circumstances when some of our application components might need to stay on-prem, or they might need to stay in a legacy environment for longer or potentially permanently. What that means is we need a way of identifying which of our application components need to be kept together. So that might be for reasons of network bandwidth and latency. It could be because of the application coupling within the architecture, or it could just be down to things like dependencies and data sovereignty issues. The ultimate answer is there are some services that need their components to be kept closely together. This is why we use the Azure Service Map tool. It's part of the Operations Management Suite or Log File Analytics. And what it does is it looks at metadata on network cards of your Azure's environment. It helps identify dependencies between components running on different machines. It helps identify the services running on a server, but also as well, it helps us identify bottlenecks that we might want to resolve. Now, some of the answers to that are keeping applications grouped together so that when you move them to Azure, you move, say, the database and the app server at the same time. Other remedial facts might be implementing a technology like Azure Service Bus Relay or ExpressRoute to make sure that the connectivity to other components is done with the right quality of service and the right speed. Undertaking a migration of virtual machines and servers into Azure is something that does require some design. There are some aspects of that design that need some careful consideration. So for example, the Azure environment you're going to deploy into, what subscriptions are going to fund that environment? Which regional data centers are you going to deploy resources in? How are you going to leverage things like reserved instances, MSDN licensing, and Azure test development environments to maximize the cost effectiveness of this environment? That all needs taking into account. The problem is for a lot of organizations, they'll actually start with a very functional design that begins with, okay, let's create this first application and host it. And then subsequent workloads just get added into an existing environment which didn't have that fundamental planning. It's really important to make that planning and to plan that Azure environment as early on in the cycle as possible, because those tend to be the considerations that are hardest to overcome later on. A lot of organizations also overlook governance and planning their virtual network and how hybrid identity management are going to work. And again, this is something that needs to be planned out. There needs to be some design effort put around this, and you need to start with the end in mind. High availability, backup and recovery, systems management, security, and disaster recovery are all aspects of your Azure design that need some consideration. There need to be some conversations had with the operations people to say, okay, how do you want to be operating this stuff? Now, fortunately, we don't have to begin from the ground up with all this stuff. When we come to implementation, there's a huge amount of automation, good practice, and reference architectures we can leverage to make implementation as easy as possible, but we have to bear that in mind at the design phase. Traditionally, one of the things that I used to hate about being an architect was design workshops. Traditionally, a project manager would say, all right, let's pull everybody together for a week. Let's book out this meeting room and we'll all sit down and we'll thrash it out. And what happened was people's energy levels would just shrink, people's attention levels would go, and it was never a particularly nice experience. What we've learned to do now is rather than have a big, massive 2 week or 1 week hothouse experience, what we do is we separate design out into separate workshops. That way, we maybe have a 2-hour workshop for each one of these areas each of these aspects of design. That means we get the right people and nobody extra in the room at the right time. We keep these sessions maxed at about 2 hours as a rule of thumb. The idea being that we start these sessions with a demonstration. So usually the first 30 minutes of these workshops, we're showing you what the art of the possible is with Azure. Then we explain the design decisions that need to happen. What are the options? What is it you want to have? And generally, what does that mean for an impact? Usually around cost or around operational capability for each of those decisions. We work with you then to make sure that jointly we make the right decisions to give you the solution that's going to meet your requirements. There's a whole bunch of design artifacts that are incredibly useful, and I would argue are still mandatory for the operations team and for the people that run this platform on an ongoing basis. However, because it's cloud-based, the level of detail that's required varies. So these design documents should focus much more upon why a decision was made and what the core aspects of the configuration are and why it's configured in a particular way. To speed up the delivery of design artifacts, we've created a whole portfolio of template solution artifacts. So the idea is when we come to write this stuff, we're not staring at a blank piece of paper. It means we can produce, after a design workshop, we can produce a highly effective high-level and low-level design document in a matter of a couple of days at most. Because what we're building for most organizations will only change through certain design decisions, it's quite easy to standardize this documentation. This design documentation, though, is a valuable opportunity for us to communicate with you and say, are we building the right thing? Is what we're building the right thing for you? So we give you the opportunity to review these documents, but what we do is we try to tie it down to one review and one rework cycle. That means we're not going to spend months and months and months writing design documents. It means the time invested in design goes into making the right decisions and creating the right approach to efficiently implement the solution as much as possible. During the remediation phase, there's 2 categories of remediation that needs to be undertaken. The first set of remediation changes needed are fairly minor. And the good news about this is most of these can be automated with the Azure migration toolset. Some examples of minor remediation changes needed are changing the structure of hard drives to make sure they work with the standards of Azure, changing the configuration of network cards. So for example, making sure network cards are configured to use DHCP rather than static IP addresses. The configuration, the generation type of virtual machines, applying missing software updates, removing management agents from on-prem tools and deploying the management agents for cloud-based tools. Azure Migrate can help with a lot of that. It's important that we call them out though. As part of assessment, we'll figure out what needs to be done because obviously these changes need to be made and people need to be made aware of those changes. But ultimately, those minor remediations are fairly easy for us to deal with. Sadly, there were some major remediation challenges that we will run into on every customer. Azure only supports Microsoft supported versions of the Windows operating system and SQL Server. That means that we've got to make sure that the OS is upgraded to a supported version and that SQL is running a supported version as well. There may be applications or operating systems that just aren't supported on Azure. Maybe that you're using a down-level version of the .NET framework or that's going to prevent your application from working. So that could drive re-architecture of your application to running on platform as a service. In the early days of migrations, we used to hear a lot of customers saying to us, we want you to move our Exchange mailbox server from on-prem to Azure. And what we used to find was that it was as cost effective and quicker to migrate them to Exchange Online. So we were moving them to software as a service. And that was also true in a lot of cases with SharePoint workloads as well. So, okay, there's a bit of a project that needs to be undertaken, but it's probably going to be more cost effective to do that than it will be to run the workload as a VM in Azure. So the challenge with these major remediation works is that there's some manual intervention required and some design effort required. So unfortunately, these are things we can't automate, but we've developed playbooks and approaches to kind of simplify these things. When we're migrating servers from on-premises to Azure VMs, we prefer to use the Azure Site Recovery Manager toolset to do that. For one reason, Microsoft makes it freely available to you for 30 days to underpin a migration. The way Site Recovery Manager works is essentially to replicate the hard drive of your on-premise servers into the Azure Site Recovery Vault, which is some secure service in Azure. Now, this communication does happen over the public internet, but it's all encrypted using secure sockets layer, and it's held in an encrypted fashion in Azure. Once it's replicated all the data across, you've got the opportunity then to perform a non-disruptive test migration. We'll talk about that more in the next slide. But when we come to actually do our final migration, the way this will work is Azure Site Recovery Manager will tell your on-prem servers to replicate up to the latest version into Azure to make sure the replica is up to date. It'll then perform a graceful shutdown of the workloads on-prem. It'll handle any changes in DNS name resolution and IP addressing. It'll tell Traffic Manager to route external traffic across to the new source. And then it'll bring the workloads online by starting the virtual machines in the correct sequence in Azure. We tend to find that you'd experience no more than a service outage of about 15 minutes for this. We tend to tell organizations to plan for a 60-minute service outage just in case we have any issues and there's a necessary need to fail back. If you're going to feel comfortable about undertaking a migration to Azure, testing is a big part of that. One of the main benefits of Site Recovery Manager is its ability to perform non-disruptive test failovers. The way we do that is we create an isolated virtual network in Azure, and we tell Site Recovery Manager to fail over your virtual machines from on-prem to that environment, but to leave your on-prem machines alone. What happens then is you then get a copy of your production environment running in an isolated network in Azure. End users aren't impacted at all. You can go in and do any sort of testing and acceptance testing you need in that environment. We generally use a point-to-site VPN and remote desktop protocol to allow people to come in and do user acceptance testing in there. But this is a great opportunity to validate that the migration has worked perfectly and to identify any challenges with the migration process that might come about. It gives us the option to go back and do any rework that's done. Once we've got the application working smoothly and it's signed off, we then create a request for change to get approval for us to conduct the actual migration. When we come to execute the final migration, we'll schedule this work for out of hours to cause the minimum possible disruption. The system outage involved typically takes less than 15 minutes, but as I said earlier, we'll tell organizations to plan for an hour's worth of service outage. What will happen then is Azure Site Recovery Manager will tell the on-premise server to replicate the latest version into Azure. The on-prem server will then be shut down gracefully, and at that point, the Site Recovery Manager is going to take care of remapping any DNS changes and IP address changes into Azure. It's going to start up virtual machines in Azure in the right order, check the services become available, and at that point, people can reconnect to the service and just get on with using it. Ask any experienced soldier, and he'll gladly tell you that the first casualty of war is the plan. No amount of planning will prevent badly timed Azure or network service outages. And Murphy's Law tells us if things are going to go bad, it's always going to go bad at the critical moment. Fortunately for us, Azure Site Recovery Manager can execute failback operations. Because virtual machines are still on-prem, they may have been replicated to the cloud, but their last copy is still there. We're able just to restart those machines on-prem. We can even potentially orchestrate that through Site Recovery Manager. Hence, we're pretty much confident that that 60-minute service outage plan is good. So we can guarantee that we'll either complete the migration or we'll start it and back out within that 60-minute service outage. Either way, we're confident we can have those servers back up within 60 minutes. Now that we've completed migration of the virtual machines to Azure, it's now time to take a bit of a step back and make sure that these machines are configured to be managed well in Azure. There are two aspects to this. The first one is about VM configuration, and mostly here we're dealing with aspects that happen inside the virtual machine's operating system. So for example, we want to make sure that Azure Backup is set up for it. That would mean installing the Azure Backup agent and making sure that the backup schedules are configured and any granular file protections configured. We need to make sure that Site Recovery Manager is configured to orchestrate and replicate the hard drive so it can be recovered in an alternative location. Making sure the management tools like Log File Analytics, OMS, Azure Monitor have the right rules and management packs in place, that agents are deployed, but also as well making sure some of the tools that make life a lot easier in Azure, like the Azure Malware Management Solution Pack and the Azure Update Management Solution Pack, are in place to provide protection and management. We also need to do some things to make sure that the Azure resources that have been created by the migration, i.e. the virtual machines and virtual hard drives that have been created by Site Recovery Manager, are configured correctly. So that's about making sure that resource tags, Azure policies, role-based access controls, availability set and availability zone membership is correctly configured, making sure that the resources have joined the correct resource group in Azure, and also that Azure resource locks are implemented to prevent accidental administration and accidental deletion of objects is in place. Now, fortunately, there's a huge amount of things that can be automated with desired state configuration for PowerShell. Now, we use that to configure things that happen inside the operating system. We also use ARM templates and runbooks to configure things happening to the actual resource themselves. In an ideal world, onboarding should be fairly autonomous. The reason why is for processes autonomous, it's generally independent. It's going to happen, it's going to be configured, and it's not something that's going to be forgotten about. That way, you're not going to come back to a virtual machine that's been migrated 3 months later and wonder why the backups weren't set for it or why it's not been monitored for all that time. When you're planning management of Azure workloads, it's important to understand responsibility for management. Azure certainly provides continuity, management, and automation capabilities that are phenomenal. Previously, it wouldn't be accessible to organizations on a smaller scale because of cost limitations. However, it doesn't necessarily implement or operate those features for you. You have to know what you're responsible for configuring and operating and what Microsoft will do for you. As you'd expect on a private cloud implementation, you're responsible for implementing and operating everything. Moving to Azure Infrastructure as a Service does offload some elements of management responsibility. So for example, Microsoft are responsible for providing hardware in terms of servers, storage, and networking. They'll take care of some aspects of virtualization management for you. So they'll take care of the hypervisor, but you still have to take care of things like how are your virtual machines configured. You're still responsible for the OS, middleware, runtime, data, and applications that run on that virtual machine. It's a little known fact though that Microsoft actually takes 7% of the cost that you consume in Azure, and it gives it to your digital partner of record. What that means is, within your Azure subscription, you nominate Microsoft Gold Partner to be your partner of record. In exchange for that revenue, that partner should be providing you with some level of support. What we do at Red Bear for customers that make us their digital partner of record, we use that to fund their entire migration. We also use that to provide a managed service. That means we'll take care of virtualization, managing the operating system, middleware, and runtime for you. That includes aspects of software update management, anti-malware management, backup, recovery, disaster recovery, capacity management, and cost optimization for you. Optimization of your workloads in Azure is a very, very important aspect of operating and managing it. There are very few things for certain in life, but here's one guarantee I can give you. You are always going to be able to make some level of savings in Azure, and you're always going to need to make some changes based on either business needs or evolutions that are coming from the technology. In terms of optimization, what's required is taking a look at the costs your resources in Azure are consuming. How much are you spending on virtual machines? How much are you spending on storage? How much are you spending on consumption? We need to take a look at capacity. Now, there are some circumstances in which you can reduce capacity. Maybe you've got a workload that's not as busy as it used to be, and you can reduce the cost of it by moving to a smaller VM. Quite often, though, where the more significant change is coming is through re-architecting your applications. And as part of an optimization service, it's about identifying which workloads are going to save you money by moving it from a VM onto a platform as a service offering, or potentially onto a software as a service offering as an alternative. Performance tuning is also something that's really important. That doesn't just happen in the way of resizing virtual machines. It can be down to reconfiguring the operating system and reconfiguring the application itself. The payback for all this is to reduce your overall spend on Azure consumption, which can be quite significant. But also as well, optimization is about making sure that you're adapting to the needs of the business as they change. After all, what's the point in having a scalable, elastic solution if you're not going to scale this stuff to only pay for what you use? One of the questions I get asked a lot is, how quickly can you move me to Azure? And the answer is, it pretty much depends on how many servers you've got. Now, for an environment with 25 or fewer servers, we're typically talking about a 10-day engagement to move you into Azure. What can slow things down is not the actual migration itself. Remediation plays one factor, so how many machines need to be upgraded to a newer version of Windows or a different OS, that has a factor in timescales. But also as well, the organization's attitude towards the migration itself. If they're comfortable with all the servers being moved in one big go, that simplifies things and allows it to move ahead a lot faster. When we move up, when we scale up the number of servers involved, generally with larger environments, there's more governance that needs to be adhered to, a bit more planning. People want to see stuff detailed in a bit more detail. That's why it takes us a bit longer to do that. So anywhere up to 100 servers, generally as a rule of thumb, 30 days is about how long it'll take us to move. We'll still be executing migrations fairly aggressively here, but one of the big differences here is that we'll be undertaking several migration sprints. So we'll move across groups of applications together. What that means is it's less disruptive to the business. It also means that we're able to tackle onboarding and management in a phased manner. And it means it's just a smoother migration by breaking it down into manageable chunks. When you start getting up to about 500 servers, we're talking typically around about the 90-day marker to get everything moved across. Now, the good thing to remember here is because we're using sprints, we can probably start executing migration sprints after about 30 days. So we're starting to move workloads then, with maybe the additional migration sprints having over the next 60 days, bringing stuff across. Once you start looking at the scale of 500 servers or more, there are some things that come into effect. So one of it is around capacity on the network for migrating virtual machines, the amount of data that needs to be moved, the rate of change at which the business can cope, the amount of workloads that the operations team can cope with onboarding. The way we plan that is essentially we'll conduct 30 days of discovery, assessment, design. Then we move into a sprint-based approach for remediation, migration, and onboarding. Typically speaking, if you plan at about 25 servers being migrated per week, that's usually a pretty safe figure to use. Now that figure can flux up or down for organizations, depending on their attitudes and depending on the amount of governance that needs to go through with it. But these are some really serious ballpark figures, and we've erred a little bit on the side of caution with these figures, but they're pretty reliable. After how long will it take to migrate to Azure? The next question I get asked all the time is, okay, we move the stuff into Azure. What have I got to do to make this mission critical? Tell me, Mr. Architect, what's good practice for operations in Azure? There is no solid manual for this. Microsoft produced something pretty powerful, which is called the Azure Scaffold, which gives you a reference architecture and a reference operations framework to work on. What we've decided to do here at Red Bear was to kind of enhance that. We've built out this thing called the Cloud Governance Framework. So the framework is designed to operate in two ways. We have the conceptual architecture, which is what you can see on the screen here. And essentially, we've identified 7 tiers of responsibility, of disciplines that need to be undertaken to operate an Azure environment. And that ranges from governance, which is about making sure that Azure resources are configured in a secure and manageable way. Maintaining and defining cloud reference architectures. What that means is having a set way of deploying workloads and virtual machines and resources into Azure. So when you come along to make changes, everything's standardized, but also as well, when it comes to change management, things are using common models. So it's easier to support and maintain stuff. Making sure there's a hybrid identity management solution in place tends to be more architecturally driven, but those things do need to be managed as well. We have a cloud security management discipline, which ensures the correct controls and countermeasures are put in place to protect against key risks that you would face running servers in pretty much any data center. There are also some cloud systems management roles that need to be undertaken. Now, this ties in very heavily with the previous slide where we talked about the watermark. So there are some capabilities you want to make sure that you have in place in Azure to make sure you can operate workloads on there. And that's everything from monitoring virtual machines, networks, platform as a service, monitoring the actual function and performance of applications at a code level, backup and recovery, DR, alerting and notifications, runbook automations, and desired state configuration. These are capabilities that we believe you really should have in place if you're serious about running workloads in Azure. If you're going to do DevOps, you also need the capabilities to make DevOps happen. Now, fortunately, Microsoft have done a lot of work integrating Visual Studio Team Services with Azure to the point that VSTS is now called Azure DevOps. And that gives you a platform for doing continuous integration, continuous deployment, getting application insights out of your apps and data stream to make sure things are performing correctly and allow you to correct them, but also as well to give you tools around environment management and environment provisioning. The final pillar of the governance framework is about service management integration. Organizations running an on-prem environment might be incredibly mature at running environment, but unfortunately sometimes there's a lot of rigidity that comes with that maturity. So there's some optimization that needs to happen, ideally across all the ITIL service management functions, but we've identified the 7 ones that most urgently need to be optimized. To give you an example about this, take capacity management. The traditional goals of capacity management is really to offset capital expenditure, to kind of make sure you make the best use of the resources that you've got already before having to buy new things. How do you resize? How do you rescale to make best use of things? At what point in time do you need to buy a new cell for the SAN? All that CapEx management goes away with the cloud. Everything's paid for on an OpEx basis. Things are also elastic and scalable. So not only is it easier to scale without any jumps in capital, it's also a lot easier to respond to business needs. Capacity management needs to work hand in hand with cost optimization. So the idea being, if your workloads are elastic, only pay for what you need when you need it, and that'll keep the costs down. So each of these service management functions needs to evolve and grow. So as the conceptual architecture for the cloud governance framework defines almost a checklist of things that need to be in place to run your workloads in Azure, alongside that, we've created the solution architecture. And what this is it defines the tools and their configuration for controls, countermeasures, and management capabilities that you need to operate an enterprise Azure environment. Whilst the governance framework's conceptual architecture tells you what needs to be done, who needs to do things, the solution architecture is essentially a scaffolding of existing management technology and capabilities that need to be implemented and configured. And we've made as much of this as actionable and provisionable as possible. You can't change the world overnight. The pace of change, how quickly your organization can change, is now more than ever going to be driven by people than logistics and technology, especially with the cloud. This is why we use a phased approach for cloud migrations and also for cloud maturity. As we go through implementing changes in the way we operate workloads, we do it in sprints. The idea being is that we create a design, implement a minimum viable product, then we'll execute several enhancement sprints. And as part of those enhancement sprints, we're not just delivering a management capability or a migration of a virtual machine, we're delivering transformation of how that workload is managed and operated as well. That's where most of the savings come from. And then because things in the cloud will change and business requirements will change and priorities will change, periodically we take a strategic review of this and say, okay, maybe we need to go back at the design, maybe it's still good for purpose, or maybe we need to change things. Maybe Azure has brought out some new kind of resource that'll make it easier and cheaper for us to do things. So again, we go through this cycle. Just as with agile development, we take the approach that we continually develop our applications. Development never stops. We keep enhancing as we go to address business challenges. That's where DevOps comes from. The same's true with our management capabilities and the resources that we're running within Azure itself. When we took a look back at the last 50 projects, there were a lot of issues that kept coming up commonly. And one of the things we found that made us faster at doing these things is that we already anticipated these issues and we already had a solution in our back pocket to deal with them. OS compatibility. There's not a huge amount I can do to help you reduce the risk of OS incompatibility. Ultimately, if you're running an old version of Windows, it's not going to run in Azure. You've either got to rebuild the server or do an in-place upgrade of the operating system. SQL incompatibility, same thing. Not much I could do to take away the risk for you, unfortunately, apart from identifying it during the assess phase. However, what you can do is take the opportunity to migrate your databases to SQL PaaS, which may be a lot cheaper and easier to manage. The point is being, if you've got to do a SQL upgrade or a SQL migration, maybe you get more bang for your bucks from the migration. We've seen a lot of issues with VMware incompatibility. Now, it might be that a customer is running a down-level version of VMware that isn't supported by Azure Migrate, or it might be that that VMware environment is just out of capacity. I mean, after all, there's a reason why you're moving away from a fairly mature virtualization technology. One of the answers we have to that, though, is using a temporary swing VMware server. What that means is you stand up some hardware that you can add to your VMware farm to add additional capacity to it. And what we'll do is migrate servers to there using a live migration and migrate them from there to prevent that providing additional overhead on the rest of the production environment. Limited bandwidth can be a real issue. Okay, you may have more than enough bandwidth to be able to operate this, but how quickly you can replicate virtual machines from Azure into the cloud, that can cause challenges if you've got limited bandwidth. So the solution there is Site Recovery Manager allows us to apply quality of service on a machine-by-machine basis, so we can cap how much bandwidth is being used by the migration. But there are also two options that Azure makes available for us to do manual data import and export. The first one is Azure Import and Export, which is where you copy your data onto a hard drive and you send it with a bonded courier to Microsoft, and they upload it into Azure for you and present it through a storage subscription. Azure Data Box is the opposite of that. Microsoft sends an engineer to your site with a physical appliance and copies your data to it and then ships it into Azure. So both of those are valid ways of getting around limited bandwidth. You can still use import-export to get a baseline replica into Azure and then just use binary delta replication to migrate changes that have happened since you moved the data across as well. Testing is traditionally something that has been a real blocker because people just haven't known what to test. Another issue that comes up with testing as well is that we'll find faults in applications when we're doing testing in Azure that were already there when they were on-prem, and the business might push back, or application stakeholders might push back on that. So the answer to that is to have some pretty pragmatic test plans. We've developed a set of reusable test plans that we use all the time, and they focus on some fairly standardized application things. But one of the tricks we've learned is, well, actually, let's execute those tests on the machines on-prem before we do any form of migration. That way we know if we've already got an application that's working already. Internet access. Do you know, if I had to put my finger on one issue that just kept on coming up for us, it's internet access, especially in the on-prem environments. Quite often people have put in place quite draconian controls over what machines can access the public internet. And doing an Azure migration means that our virtual machines do need to communicate with the Azure Site Recovery Manager service. Now, all that traffic secured over port 443 using SSL, but It may be that we need to get somebody to change network firewall rules to allow that traffic to flow. Now that means change planning, and in some circumstances, it might mean executive sponsorship. There's been a number of times where I've run into problems with service providers who've actually had to go out and engage a contractor to come in and make changes to their own firewalls because they don't know how to do that. So making sure the customer knows about that, making sure that's something that's planned for from the outset is important. Time and time again with any project, having an exec sponsor is vital to success. When you hit these kind of roadblocks that are more political, this is somebody who'll turn around and say, well, actually, this is what the business works. So you better move yourself and get this done because this is what the business wants. So having exec sponsorship is really important. Another blocker we've seen in a couple of occasions is private cloud service providers. So it might be that the customer has moved to somebody else's hosted data center. And obviously, those vendors are going to be pretty guarded about not wanting somebody external to come in and mess with their environment. And to be fair, they're going to try and do as much as they feasibly can to keep workloads in there as long as possible. After all, it's in their business's best interest. So tools like Azure Migrate and Site Recovery Manager can be difficult to implement if you can't access VMware or the actual hypervisor. But there is a workaround to this. You can deploy the Azure Backup Agent into a virtual machine. You don't need any external access, and as long as your machine can access the public internet, you can back it up to Azure, and then you can do a kind of manual recovery across. Okay, it requires a little bit of extra work around the migration, but it is a way of getting forward with the migration out of a virtual private cloud supplier's data center. Quite often when we're doing these kind of migrations, people are wanting to get out of a legacy data center because it costs too much. And it's a great way of moving it forward. Application owners as well, these are important people because ultimately their jobs are on the line if applications don't perform right. In some cases, they can be reluctant or resistant to change. Some people do fear the cloud because they think that automation is going to put them out of a job. So it's important that you work with these people as sponsors. You show them that you've got a pragmatic test plan for their application. You show them that it's going to perform well in that environment. By doing a test migration and testing it out, you can go a long way towards proving to these people that it will work. But again, having an exec sponsor who can come along, click his fingers and move political roadblocks out of the way if people are being unreasonable is a real feather in your cap here. So that's everything I wanted to present in this video. Now, obviously, we've got limited time. We can't talk about absolutely everything. So what I wanted to do now is introduce you to our Business Development Director, Cindy Hast. What you can do if you want to get more information, or if you want to talk to us about how we can do your migration for you, funded by Microsoft, or provide a managed service for you, again, funded by Microsoft by making us your partner of record, please reach out to Cindy. She'll make sure that me or one of my technical team answers any questions that you come up with, and we can also help you plan your migration. So feel free to reach out to Cindy, even if you just want to ask a question. Thanks very much for taking the time to watch this video. I hope it's been useful for you. Please feel free to get in touch if you want anything.